Okay, thank you everyone for joining us on this webinar. My name is Vikram, and I am joined on this webinar with two of my colleagues, John Phipps, our senior engineer, also working out of our Gaithersburg, Maryland office with me, and Madhu Das, who is joining us from India. Madhu is also our senior engineer. Thank you very much. Let's go ahead and get started. Today we are going to talk about our session initiation protocol testing solutions. So SIP testing solutions. It's one of our most demanded and best-selling solutions that we offer. So let's go ahead and get started. We are GL Communications Inc. We are located in Gaithersburg, Maryland, just north of Washington, D.C. We also have a development office in Bangalore, India. That is where Madhu and Sanjeev are joining us from. We also have a sales representative office in Shanghai, China, and we work with sales representative companies all around the world. We sell worldwide. We have been around for over 35 years. We manufacture telecommunications test and measurement equipment. We also provide consulting services, software development, hardware development, and managed network services, and so forth. So in terms of our products, we sell hardware and software that can interface to many different telecommunications networks, including VoIP networks, analog networks, T1, E1 networks, fiber optic networks, wireless networks, all the way up to 5G, and so forth. So we have test equipment that can interface into all of these networks. We can monitor traffic, we can generate traffic, we can store traffic, we can analyze it, we can visualize it, we can do a whole bunch of different things when it comes to telecommunications testing and measurement. So that's a little bit about us. Again, I think a lot of you are familiar with us. So let's go ahead and get started and talk about SIP. So session initiation protocol has become a ubiquitous technology. It is used for transmission of voice, video, chat, fax, all sorts of different things over internet protocol. It's flexible, it's interoperable, it's scalable. It's been adopted globally. Many other protocols use SIP. So things like real-time transport protocol is encapsulated within SIP. Session description protocol (SDP) is used by SIP, and so forth. And of course, SIP can ride over UDP, can ride over TCP, and so forth. Also, there are specialized implementations of SIP for different types of mission critical networks. For air traffic communications, ED137 is a protocol that allows pilots to talk to air traffic controllers on the ground, and that ED137 protocol is actually based on SIP. So air traffic communications these days is migrating to SIP. Also, next generation 911 and emergency services uses SIP. These days, when you dial 911, you can call you can transmit voice, but you can also send messages and pictures and video and so forth to emergency services, and SIP is the protocol which facilitates all of that. So SIP is extraordinarily important. It's probably the thing we get asked about the most is our SIP testing solutions. Okay, so we have a lot of different emulation solutions. So we can fully emulate the SIP protocol. All of the headers, the payload, everything about SIP, we can control it all. So all the protocol headers, you can edit it and make it how you desire. So things like the calling number, called number, codecs, all sorts of different things, IP addresses, and so forth. We have full control over that with our emulation software. We can do SIP-I, we can do conformance testing. We support IMS. We support ED137, as I mentioned. We do fax and so forth. So we have a lot of different software licenses that are based on our SIP testing tool, and it's all based on the same framework. And then it's just additional licenses depending on if you have special use cases. So it's a very flexible software program. It runs on Windows operating system. If you just use it on a simple laptop with a gigabit Ethernet card, you can generate up to 2,000 simultaneous SIP calls from the software alone. So that's usually sufficient for a lot of customers. But if you need to go to higher load, we offer a dedicated hardware appliance that I'm showing here at the bottom of the screen. And that hardware appliance can actually generate up to 64,000 simultaneous calls in one single self-contained system. So if you want to do load testing and really load down your network infrastructure, we have this tool which we call our MAPS HD testing tool, which can generate tens of thousands of calls into your network. We'll talk in more depth about all of this as we go through the webinar. But also in this graphic here, I want to mention that we can simulate not only the user agents, we can also emulate servers, proxies and registrars, redirect servers. We can emulate IMS core network elements like this PCSCF or SCSCF and so forth in the IMS core network. So we can do a lot of different types of emulation in addition to just making actual SIP calls. Okay, so some of you may be familiar with our message automation and protocol simulation testing tool. We abbreviate it as MAPS. This MAPS testing tool is very versatile. It can generate traffic over a wide range of protocols. We're showing just a subset actually of all the different protocols we can emulate with our MAPS testing tool. So we can actually emulate TDM protocols like ISDN, SS7, and so forth. Even analog phone calls over emulating FXO or FXS interfaces. We can do wireless, 2G, 3G, 4G, 5G. We can emulate the core network and so forth. Today, we're going to mainly focus on SIP, but if you have any questions on any of the other protocols that we can emulate, please let us know. This MAPS tool can be deployed in many different types of environments to test your network infrastructure, to see how your infrastructure behaves when it receives certain messages, valid messages, invalid messages. How does your network infrastructure behave? Does it react appropriately when it receives different types of protocol messages? So this is a very powerful tool, MAPS. It runs on Windows operating system. It's a very easy to use software program. You'll see the graphical user interface in a moment. We also offer Python and Java scripting capabilities. So if you want to do really complex or repetitive testing scenarios, we can support that using scripting. So if you just want to do simple tests where you click buttons in a GUI, we support that. But if you want to do repetitive testing, thousands upon thousands of tests over days, weeks, months, we have scripting capability which can help you with that as well. So this is probably our best-selling software tool. because it's so versatile in the types of traffic and scenarios it can support, MAPS. So like I mentioned before, we can supply a software-only version of MAPS. You can install it on your own PC. We can provide the PC. It's a pretty lightweight installation, honestly, but you would want to use it on a PC that has a gigabit network interface card and Intel i3 processor or higher for optimal performance, 16 gig RAM for optimal performance, and so forth. But anyway, besides that, it's very easy to just install this on any Windows PC, invoke the software, and you are good to go to start, generating traffic. We provide all sorts of sample scripts and profiles and default configurations, so it's very easy to just modify those and kick off calls and things like that. From a simple laptop PC with a gigabit NIC, you can generate up to 2,000 simultaneous calls. Like I mentioned, if you want to generate up to 64,000 simultaneous calls, we can provide a dedicated hardware appliance. It's also a server-grade PC. It runs Windows, but it's got specialized network interface cards, 8 gigabit Ethernet ports that we've specially built and configured. They run wire speed, and they can generate and receive traffic at wire speed, full gigabit rate, without loss. And therefore you can generate up to 64,000 simultaneous calls. You can actually buy multiple of these systems and control them all from a master system to generate even more calls if you need to go beyond 64,000 calls. I'm showing a rack mount form factor. However, we also support portable form factors. So if you needed something that you needed to take out into the field, but still do a lot of heavy duty load testing, we have these portable lunchbox type PCs that can assist you. So portable or rack mount or a simple laptop, it can run on a variety of platforms. Okay, so some of you on this call are probably more familiar with SIP than I am, but basically we have full control. When we generate the SIP traffic, we are fully compliant with all of the RFC standards for SIP and the ETSI standards and so forth. We can test SIP conformance according to the published ETSI standard. We support a whole bunch of different SIP extensions according to all these standards you see here. We support encryption via the secure real-time transfer protocol, so we support that as well. We support MSRP according to that RFC standard. All these different types of SIP variants and extensions, we support them all. Recall that SIP operates over IP, and it usually runs over UDP, but you can also use TCP. And basically, when you use the MAPS tool, it'll generate the full Ethernet frame with the encapsulated IP packet and the UDP and the SIP packet and so forth, plus the MSRP, SDP, and whatever. So the traffic is fully customizable and conforms to all of the latest RFC standards. Okay, so SIP is predominantly used for initiating calls, maintaining calls, and tearing down calls. So we refer to all of that as signaling, and all the call establishment and so forth is signaling, and we support all of the different types of signaling scenarios with our MAPS for SIP tool. In terms of the actual traffic, the audio payloads, video payloads, whatever it may be, we support all of that as well. So we support RTP if you want to send audio or video streams, facts, tones, digits. We support all of that through putting it by putting it in RTP packets. We support all the industry standard voice codecs. So I list a lot of them on the screen here. G711, G722, G729, blah blah blah. All of the different voice codecs, we support them, and so forth. So traffic and signaling, we support all of the different types of scenarios that you would want. And finally, automation, like I mentioned, like we'll talk about, we can run tests 24/7. We can automatically schedule tests, execute tests, get reports periodically, things like that, using our automation capability. Okay, so I'll stop talking after this slide and turn it over to John. But let's just quickly review like a standard SIP call. What happens is you have a user agent that's placing a call, but first all the user agents need to register to this SIP registrar. So they all register to the SIP registrar, and then you can start initiating a call, sending an invite message, and so forth, trying messages, ringing messages, acknowledgements, and then when you're ready to tear down the call, you send that the buy and the acknowledgement as well. So this is every single step of the way. You can click on the MAPS, the actual packet in MAPS, and see what exactly happened. Every time you receive a packet, send a packet, you can click on it, see exactly what happened, get the full decode. If there's any error, if you don't get a 200 OK, if you get some other error, you can click on it, see exactly what the error is, and see what went wrong, and things like that. So with the MAPS tool, you get the full ladder diagram. You can click on any one of these events and get more information on the call. So that's how we dissect the full SIP call. Okay, at this point, let me go ahead and turn it over to John, and he will do the next several slides. John, go ahead.
Okay, so yeah, this is basically what the previous slide was showing. You can test a device under test could be like an IP-PBX, for instance. One thing to note is that you can't make a call from a user agent client to user agent server directly on the same IP. That's a call of hairpin turn, so it's not supported. So you need to make a call out to another IP that will send the call back. The MAPS SIP also allows you to decide what you want to do with the call. So you have the options of making the call fail, so you can have all the standard fail messages going, for instance. But basically you can also test gateways. So on the left-hand side, we have the MAPS SIP. On the right-hand side, we have MAPS CAS ISDN SS7, and that handles the T1 side of or E1 side of the connection. So you can make a call from the IP to a gateway where this call would be converted back into the TDM world or analog world, and back to the MAPS CAS ISDN SS7. Okay, so the first thing, you basically have the RTP core address. This is the basic configuration. This would be the IP that the MAPS SIP is running on. And there's a CSV profile. You define a user agent profile, and the profiles define all of your call user agents. So if you want to test one set of parameters, you can set it up in profile 3 and set up another set of profiles and set them up as a profile 27. And then when you start the test bed, then you define here which profile you want to use. And we also have a capability of using a CSV file. So if you want to do bulk testing and you have lots of call user agents that you want to assign, then you can just load up a CSV file. And we also support IP spoofing, so you can assign more than one virtual IP to the NIC card. So in the global call configurations, so the third one down is the call duration in milliseconds. So that's showing a 60-second call as a default time. So you set up a call that'll last for 60 seconds and it will automatically turn off. If you put a duration into the actual profile of the individual user agent client that you've configured, you can actually change the timing on that. But you can see it has all the different variations on different parameters for setting up different timers, create sessions, and things like that. So under the user configuration, if you have a, well, it's not shown here, but if you have a proxy that you need to, like an IP PBX or a registrar somewhere, you can put in the IP destination, IP address, the call type, audio call, but you can select video calls, instant message calls, various combinations. The contact address would be a telephone number on the actual server. The address of record would be the address at the proxy if you're using the proxy of the IP PBX. And the two addresses, the destination. And if you roll through the bottom, you have the different other parameters like the whether you're going to use SRTP, any display names, the SDP parameters, so you can basically define where the RTP is going to go. So you can make a call from your telephone and send the audio someplace else, for instance. The SMS call parameters, and the codecs, for instance. So you can define the traffic type. So the very bottom is showing the auto traffic type is file. The other options, like you can send no audio. You can send a fax call. You can set it for TX only, receive only. You can also add impairments. And there's a quick config option. So there's a little yellow light bulb that you can use to set up a user agent, say your to number. You can say quick config and say I want to call from 0001 to 0025. Tell it to do that, and it'll automatically fill in all the different profiles with the parameters you want to configure with the application. So as I mentioned, we have you can send voice files, fax files, packet impairments, digits and tones, instant messaging sessions, and bulk and manual call generation. So as Victor mentioned earlier, so you can have 2,000 calls with your standard MAPS SIP and 64,000 for the big unit. So this is the your basic call screen. So you basically have a script name. So the SIP call control is the basic script that handles all outgoing and incoming messages. We have quite a few other different scripts. When you get into a SIP conformance, for instance, there's specific files that handle specific test cases, and we have files that we use, they're custom for, say, E911 service testing. But basically, you just give it the basic script tell it what profile, and say start, and it will go off and initiate a call. There's a button here that says start all. That's someone, there it is, can use to start. In this case, if I wanted to start all 10 of the calls, I could just hit start all and it will start them all up. What this is showing is that you have the ability of starting them all in a sequential manner. So you can hit start all and it will start with call 1 and we'll step through to all 10. If you hit it, the one to the right of that red arrow on the top there, it'll start all 10 all at once. And so it also will, we have RTP measurements, so it'll will give you parameters such as the MLS score, packet loss, packet discarded stats, things like that. And then we have event logs, so that when if there's an error that's a captured error tab, so you can see what's going on. If you have any issues, you can call us up, and we'll get on with the Teams meeting with you, and we can look at the log and say, okay, and obviously to help you out. So the error events is, in this case, it's not actually error events, it's just things that are out of the ordinary. So we expect a normal complete call if the call fails for, in this case, like a 480 or a 606 message, or saying something has happened out of the ordinary, and just throws into the error events is it an error in terms of a normal calling. And otherwise, the event log just shows you what it's doing, invites and progress and that kind of thing. So in load generation, this is showing 2000. So if you had the HD version, you can like as you said that we can do 64,000. You have different options, step, ramp, sawtooth, thing, that kind of thing. And basically, you define the script that you want to run. So if you have special custom scripts, you can use those as well. Well, not that the messaging is text-based. So if you want to customize your messages, it's fairly easy to do that. You can just go into the actual message, add lines, and you can actually get it to the actual GUI as well. And that's one reason why we have, say, the ED137, because they needed specific messages that had to be added for the push-to-talk button for a microphone when the pilot wants to call the tower. And so that was integrated into the application fairly easily. And then we have some graphs so you can get an idea of what's going on with your calls per second, the numbers of simultaneous calls, and on the stats, you can see the number of active calls, how many you've done, how many you passed, how many you failed. And then we also have a table with the stats. So we're sending out calls and receiving calls, and you can take a quick look at the tables and see how things are going with that. Yeah, so Vikram wanted to talk about the voice quality testing, so I'll pass it over to him.
Okay, thanks, John. So we can do voice quality testing as well. So the MAPS program can send audio over the network and receive audio at the other end. And that audio will experience some sort of degradation, right? Over the network, there'll be some packet loss, bit errors, and things like, and reduced bandwidth and latency and so forth. So that will all result in a degradation of the actual quality of the audio. So what we do is we take the original audio file, and then we take the received audio file, and we compare them using a industry standard algorithm such as Polka or PESC. and we compute a mean opinion score on the received audio. So it's a very nice setup. We use another piece of software called our voice quality testing software. It can be installed at a central location, and then the MAPS programs can send the audio files to the central location where the analysis is performed. We also include a nice web-based dashboard that you can log into from anywhere actually and see the actual voice quality scores. So if you are interested in voice quality testing, it's very nicely integrated with our MAPS program. And the nice thing is that, again, the voice quality testing also can be run manually, or we also support scripting and automation, so you can take hundreds or thousands of voice quality measurements over the course of hours, days, whatever, and then and get lots and lots of testing done in different types of scenarios. So it's a very nice feature that goes along with our MAPS tool. So I'll turn it back over to John. Let's now discuss fax testing.
Yeah, so we can send and receive faxes with MAPS SIP. We support both pass-through and T38 protocol. So, for instance, on the slide we show an ATA, and this is a G711 pass-through. If you're making a call from an ATA, it may or may not support T38, for instance. And if you make a call to a T38 device, the destination side is the side that decides which protocol to use. So if you make a call and you don't support the RTP, and that device is trying to set up as T38 only, the call is going to fail. So that's one way you can test to the signaling. The simulation supports the standard fax rates as well as VFast, so we can go up to the higher speed faxes, and it supports multi-page fax. So we've had people that wanted to make a test where they're going to send 100-page fax through their network, and they've called us up and said we need a 100-page fax, and we've had to send an example through to them. We have very good quality or customer support here. Yeah, so the regular pass-through RTP would be sending the standard T30 protocol over the wire, basically, or over the network. And so you have all the standard fax messages, the DIS, DCS, multi-page signal if it's going to be multi-page, or if you're in the error correction mode, there's slightly different messages. So in the T38, it uses, but basically what happens is in T38, the messages are encapsulated in something called the UDP-TL, which is the UDP transport layer. And the messages are decoded, put into specialized packets, and sent over the network in that way. One of the problems with the pass-through RTP is that fax is very sensitive to things like packet loss, jitter, and that kind of thing. So if there's a lot of network impairments, T38 was basically developed in order to get around all these different issues. And so here's what the screen looks like. You can see, for instance, in this slide, you see an invite, and the call is answered, and it basically would, in this say, would detect it's going into a call that supports T38, and it'll send a re-invite to initiate the T38 protocol, and this creates a high rate 33.6 fax, and you can see through the ladder that it shows you the different messages again, like the call subscriber information, the digital identification signal, digital command signal, and that sort of thing. And you get a decode on the other side. And the same thing under the event log. You can see all the different messages that have been received. So the ECM mode, that's error correction mode. Modified read is the encoding standard. Page initiation of the page has begun to send, that kind of things. And in this case, it's a multi-page fax, so you can see there's additional pages being sent. And you also have video call generation, so we support, there's basically a canned video with options for like H.264 and H.263.
Okay, thank you, John. So let's talk about interactive voice response. We can also do a lot of IVR testing. So just to recall, what is IVR? So interactive voice response. So when you dial into something, you receive some automated prompt. Dial 1 for technical support. Please press 2 to speak with an agent. Please press 3, and so on and so forth. So those voice responses, we can test those voice responses. If you set up a call center and you have these automatic voice response systems, the MAPS tool can send calls into that IVR and then see if the response is accurate. So we have this speech to text capability where we will dial a call, we will hear the, welcome to GL Communications, please press 1 to speak with the agent, something like that. And we will record that speech and transcribe it to text. And we can actually traverse the entire IVR tree. So we can dial digits. You can tell it ahead of time which digits to dial and how long to wait, and then dial the digit, and so on and so forth. And you can get a full transcription of the whole whole response process, and to verify that that the IVR did the right thing, gave you the right response, and directed you to the right place. So with the MAPS tool, we have done lots of tests for customers where we generated automatic calls to their IVR and confirmed or found flaws in their IVR system. So for instance, we ran it. Here's a very simple example that we did on our own IVR. If you call our phone number, and you'll immediately hear, welcome to GL Communications. If you know your party's extension, please dial at any time, blah, blah, blah. So press 1 for sales, press 2, and so forth. And so we get all of that audio back, and then the MAPS tool will automatically transcribe it to text, and then you will see it in the MAPS software exactly what the text said. And so that's very cool. That's something where you can make sure that the IVR is performing correctly. We can also generate a prompt at the we can generate a report at the end of the test. So we can do things like, okay, what was the received prompt and what was the expected prompt? And if they're different, then we can generate some sort of similarity score, and so forth. And we tell you the stage. So if it's like a nested IVR where you press 1 and then press 5 and then press so on and so forth, it'll tell you at what stage the event occurred and what the event was, and so on and so forth. So and this is all customizable too, because we're doing things through a script. We can customize exactly what you want us to look for when we traverse the IVR. Okay, All right, so we don't have much time left, so I'll turn it back over to John. We'll talk about a few more applications that we can do with MAPS, the first being message session relay protocol. John, go ahead.
Yeah, another thing I said with the previous one, we've done tests with the call centers where they expect to be able to handle 100 callers simultaneously, and we get into a live traffic testing, they get to 50 calls and everything goes overboard. So then they have to go back and we've gone through like 3 or 4 iterations while the customer call centers are trying to get their call service to be able to handle the call loads. So for the MSRP, basically it's text messaging. We have a file you can basically put whatever you want to into a text file, and we can make a call, and we use it mainly for A911 voice testing. We do quite a bit of this into the public service access point, that's the PSAP testing, and we'll send, and then we can receive the text and make sure that everything gets sent properly. Yeah, so this is basically an example. So the call is up, and then we're sending the message, and we're getting 200 OK and reports back. So it's fairly simple and straightforward. And the same thing for a stats. So in this case, we've sent 340 text messages out, and we received 345. So this is an example of a real user's case that you may be receiving more than you're sending. So we have MAPS SIP IMS. So basically, it's able to generate calls into the IMS network, and so you can simulate calls from, say, a wireless into the network, and so we can basically make a call into the SCSCF and out to the destination. So our MAPS products, we can emulate the entire IMS network, and then place calls and emulate all the various bits and pieces of it. And it's 3G as well as the 2G up to 5G, volting, all the good stuff. SIP conformance. So basically, there's an ETSI standard for SIP, and we can emulate, or basically we emulate all these different script names, and each one conforms to a specific test. One thing I would note is I've tried running conformance testing against Cisco and all sorts of different SIP IP PBX emulation, and all of them seem to fail in one place or another. So if you're trying to implement an IP PBX, for instance, you can use it to go through all the different steps through the protocol that will help you debug any issues that come up. And so basically you can call up, they're set up in a different blocks, and you can step through the different steps, and it'll go through and we'll give you a report of the results, pass or fail. And this is an example of proxy conformance. So in this case, it failed because there were too many hops. So the request failed.
Okay, so the final topic we'll talk about is our automation capability. We support Java and Python APIs. You can actually you can run the script from anywhere actually on the network. So you can have the MAPS system somewhere else, but it's listening for API calls from your Python or Java script, which could be elsewhere on the network, on maybe your own PC or something. As long as your PC with the Python or JavaScript is able to talk to that MAPS server, you can execute the script, and then that MAPS software will execute all those commands and then generate the test traffic. So we support scripting, and the scripts do not need to be run on the same system that the MAPS software is installed on. It can be run from anywhere on the network. So here is just like a little snapshot of a simple Python script. We provide sample scripts when you buy the product, so you'll be able to easily edit these scripts. They're not hard. We comment them. And even if you don't know much about Python or Java, you'll be able to look at the script and easily edit certain edit certain variables like IP address and so forth, and just execute the script. And from a nice Python shell, you'll get all of your statistics anytime you want them, and so forth. So the scripting capability is one of our most powerful features. A lot of customers ask for it, and we provide full documentation, comprehensive user manuals on all API commands and sample scripts, and we can provide assistance as well to help you get started and review your scripts for you and things like that. We can also write custom scripts for you. So if you have very complex testing scenarios, we can write the scripts for you. And so we can do that as a service as well. Okay, thank you all so much for listening this whole time. I know we covered a lot of information. You can also email us at info@gl.com to discuss your specific requirements. I appreciate it, and no matter where you are in the world, thank you for joining us. Have a great rest of your day, and again, please contact us at any time, and we'll be happy to talk to you. So thank you very much.